get started. Okay, we're going to get started on block 2. So welcome back, everybody. I hope you had a great coffee break, you had some nice discussions, and we'll get going now on the second part of the event. From vision to delivery, so innovation in action. We are going to present an overview of FLPP, of the main pillars we're working on, and then we'll go into detail into some of the applications, the results we have, and then we'll have first sustainability awards at the end of this block. We're going to start off with FLPP at a glance. So we're going to present the highlights, the main themes of our program proposal. And you've heard about this. I mean, hopefully everybody knows this all by now. For several events, you have heard about the activities that we are working on, and Pierre will present them as well earlier. So we'll get a short update on each of the initiatives in SPOC, Thrust, BEST, and first by FLPP colleagues. I actually wrote, I'm eager to see what's going to be presented in block 2, and that's funny because I'm actually the first one to present. I'm going to be presenting Thrust to you, which is this high thrust stage combustion engines for reusable space transportation. So this is one of the 4 main pillars of FLPP. It's something we already have ongoing. We currently have 2 Thrust projects ongoing, one with RFA and one with the exploration company. They started off in end 2024. They're working on components for high thrust stage combustion engines. They've already done hot fire tests. I think we'll see a film of some ignition system technology testing by the exploration company. RFA are progressing well on their side as well. So we have ongoing contracts that are focused on technology demonstration for stage combustion engines in Europe. It's a clear case, and again, Pierre mentioned this earlier, it's a clear case for action. High thrust engines, they're enabling elements for heavy launchers. And specifically on stage combustion in Europe, we don't have that cycle at this kind of level of thrust as a part of our capacities right now. So we are enabling that in FLPP through our Thrust program. It is also one of these programs, as becoming more and more, that is competitive. When we did the first call for Thrust, it was an open call for competition. Anybody with a plan for an engine could propose something, and we now have these 2 parallel contracts running. And we're solving this bottleneck European space economy. So it's this point, again, that was also mentioned by Jerome this morning, earlier today, about preparing. We've done the ministerial 2025, is preparing the next ministerial and the next launcher. It's always looking ahead and making sure we have the building blocks and the elements we need so that when we need to go, and that's it, we're going to get the heavy launcher, this is what we need to do for the next system, we have all the elements in place already. And obviously, as we all know, building an engine, especially a staged combustion engine, here we're talking about at least 1 meganewton of thrust. It takes time. So we have the first batch running already. We got funding from the ministerial conference, so we will release ITTs this year in 2026. The first contracts we have running now are components. There's some subscale elements, there's some components. We will ask this year for testing of full-scale engine subsystems. So full scale is above 1 meganewton thrust. Stage combustion engine, we could be talking about combustion chambers, injector heads. It could be some of the pre-burners or even the turbo pumps. This is all, again, in preparation. So we're going to do a competitive call for Thrust 2. It's going to be open again. And then it's working towards, ideally in 2028, we move on to something more like challenges. So the first full-scale engine test, the first company to achieve full-scale hot fire test in Europe would win the challenge, or elements like this, with, again, about 1,000 kilonewton to 1 meganewton thrust. So we are doing this already. We have the funding. We'll continue doing this, and we'll expand to full-scale systems this year based on the funding from Ministerial 2025. And we're working towards a proposition from Ministerial 28, where we start talking about full-scale engine testing in Europe, stage combustion engines, in 2028 or 2029 would be our objective. And again, I'll do a little teaser. We have another event tomorrow on access to space, future access to space. We will discuss about this, specifically about engine testing capabilities. So there's the element of actually the engine components themselves, and we also need the testing capabilities in Europe to be able to get that engine test before the end of the decade. So that is Thrust, and then I'm going to move on to BEST now with Antoine.
Thank you, Kate. A few words on the status of BEST. BEST is faring much better than my voice today, so thank you for bearing with me. We're well into our second year with the project. And I'd like to shortly recap what we have launched so far. One of our two projects, maybe if I illustrate it better, is with Ariane Group, working on the liquid reusable boosters concept for Ariane 6. This is a project that answers a very interesting question for reusability, and that is, can we introduce reusability in our existing launch systems as an incremental development, not a brand new launcher, but rather as a derivative, a new version? And that also means, can we maximize the synergies that we have in European projects developing reusability? That is Prometheus, Themis, that is existing launches such as Ariane, but also new developments happening in space companies such as MySpace. So we are starting to get results in this, and in particular defining how this makes overall sense, economic sense to start with, but also technical sense. And we're seeing areas where we need to innovate, areas where we need to manage complex consistency problems, and areas where we need to invest in testing. So that's exactly what we had set to do. We're happy to say that we are going to reach first concept reviews in a matter of days, and the project is ongoing till the end of this year. The second project that we're working on is with ESA-Aerospace, a different one, but also fully in the objectives pursued by BEST, because ESA-Aerospace is tackling reusability by placing the questions in the right order, to draft a long-term plan for future launches and to see how to embed reusability in it, how to approach it. And this leads to a range of trade-offs, of technical problems that are being explored. So the main characteristic of this project is a fantastic asset that can be put to use here, which is the Spectrum launcher, that can serve as a test bed for experiments in reusability. With all these assets, we're also progressing towards concept key points this year. And I'd like to say that these two examples are in a way satisfactory to us, as they show that this method that is being tried with BEST is successful, as it encourages the industry to take ownership of the logic of developments. It encourages the industry to seek for full consistency of economic investments, projections across the life cycle of a reusable launcher, technological maturation, systems consistency, and hence we, as an agency, we can make sure that investments in reusability are always as consistent as they can be. So what can come next? Of course, there will be decisions that have been announced in previous status of BEST that these projects may continue, but also we want to add to them, and we want to launch a new round of BEST studies, starting as these ones were with concept studies, phase 0A, to add new players to the ecosystem, to add new opportunities to de-risk European reusability, and that is what will be on our plate for the next months to organize this. Thank you very much, and now I hand over to InSpace with Agatha.
Thank you very much, Antoine. And yes, short update on InSpace. So most of you should know it already. The key points within InSpace logistic ecosystem is the implementation of this topic with the so-called minimum viable products coming out on various InSpoc steps. So InSpoc 1, around rendezvous docking refilling. Here, this activity phase P2 is ongoing currently. So this is the topic which will be running around until end of the year. And then later on, we will see for the implementation and the pace of the next step, where obviously the objective will be to do the in-orbit demonstration of this activity. The next step, so InSpoc 2 around cryogenic management and refilling. Here we have finalized 5 contracts which have been, which were very successful. So again, depending on the implementation plan, we would wish to continue this activity, especially that cryogenic has quite a few topics to cover in order to make it really reliable in space. InSpoc 3 This is also the topic. So the third step, onboard and shared intelligence. Here we had 7 early stage studies ongoing. All of them are finished. So we would wish to launch the next phase. We see that this topic will require much more work because this is really the one which is the newest to connect with the hardware activities. So here we think we will need to again do more preparation phase in order to link correctly software companies with the hardware ones. And the INSPOC 4, this is the youngest one. This one, actually, we had a successful OZIP call and the pitch day. And here we will be launching soon the ITT. At the end of our event, you will see what is the plan, but this one is something for which you can look for if the topic is interesting for you. And all this is in the preparation of the activity related to in-space infrastructure, so and especially in-orbit refueling stations, so Odyssey. This one will be postponed to the later stage in terms of the demonstrator, but definitely we would like to accompany so that all the ecosystem connects properly between MVPs and demonstrator. What is related to that is also, as we call in-space or INSPOC application cases. There are 2 contracts ongoing related to that. One was mentioned today by Bob, which is regarding the ground demonstrator of cryogenic refueling. So this is connected to the interfaces also, which we would like to have from the INSPOCs. Second one is the contract called Raven. So it is the in-space transportation vehicle managed on the Polish side. And this one here, we have the phase B1 ongoing currently in order to prepare to the next phase, which will be 2, which will be starting around the end of the year. What is key for this also is the in-space transportation club. This is the area where we connect all the in-space ecosystem, be it providers or clients. So here currently we have more than 600 active members. Keep a watch on this because this may become even bigger community. This topic will be addressed later on in the panel of the third part related to ISO's ISAM. But definitely, if you are interested in the in-space transportation club, contact us because we are gathering the new members if you are interested. Thank you very much. And I pass now to Luis.
Hello, good afternoon. My name is Luis Escudero. I'm manager of the Technology Disruptors team in FLPP, and I am also responsible of FIRST initiative. So in this frame, I have the pleasure to introduce this topic, which will also be treated in the next 2 points in the agenda. So most of you know it, but I have to start from the beginning. Sorry for this, for the ones that you know, but very quickly about the context of FIRST. FIRST stands for Future Innovation and Research in Space Transportation. The goal of FIRST is to de-risk technology disruptors, which are key for future space transportation, and to do that in open competition, rapid prototyping and testing. For this, we need European industry. We need technology providers maturing the technology disruptors. But in FIRST, we need these technologies to be commercially interesting, commercially attractive. We have seen this in the dual panel discussion. It's important for our technologies, for our activities in FLPP to have a market, to have commercial attraction. So for this, we need not only the technology providers, but also the space transportation service providers, the primes, who will be the final customers of the technologies, who will ensure the market for the technologies that we develop. And we welcome also investors in the loop. And we launch our first activities in 2 stages, a stage with a call for ideas in OSIP. Afterwards, we invite some selection of ideas to a pitch day. And we invite also the space transportation service providers to present their needs so that then afterwards the technology providers can address the technologies towards these needs and to ensure that there is a market behind. So we have launched, we are happy to have had a very good welcome of FIRST in the European industry. You can see some statistics there. And we have 6 campaigns before CM25. First, initial campaign for structural materials and processes, then avionics and GNC, then propulsion, reusability, then sustainability, and then simulation and intelligence. And these ones are each of them in different steps now. We will have testimonies of them later in the afternoon. And what will change after CM25, some parts will remain constant because we have seen that it has been very much appreciated by everyone. So there will be the usual previous activities with similar budget, similar TLL objective, but we intend to launch also in parallel of these activities, other activities with higher budget and higher TLL objective. And we try to reinforce also the links with SMEs and academia. So the launch of first campaigns will be every 6 months. We have launched already first campaign number 7 for structural materials, mechanisms, and processes. This one is in the call for ideas. You still have until the end of the week to present your ideas. If you have not done it and you are interested and you didn't know the approach, please come to me or to my colleagues. So the call for ideas closes the end of the week. We have a pitch day on the 9th of April, and then we plan to launch the ITTs mid of April. So this is for the new first, number 7, and then we will launch every 6 months on different topics that you see on the slide. And just a quick reminder, there is also first simulation and intelligence. The ITT is open, and it's open until the end of the month. So if you have interesting proposals there, please check. For this one, of course, it's needed an ESA proposal, so it takes more time. But for first structural materials and processes and mechanisms, it's very light, you will see, and you can already send an idea if you have not done it. And I think that with this, I close my intervention. Thank you very much.
Thank you very much. We're going to stay on stage. Antoine. Obligatory photo. Thank you very much. Right, so we've just had FLPP at a glance. So my colleagues and myself have presented an overview of the main themes of what we're working on right now. And now we want to take you into something much more concrete. We'll go into some of the projects more in detail that Luis started presenting. So it's going to be first avionics and GNC, where we have the projects some of them coming to their successful conclusion. And my colleague David Riley is going to present these projects along with his panel.
Great, thank you, Kate. Thank you, everybody. So as Lewis just presented a moment ago, I'd like to remind you of where we were back in the FLPP autumn session in October 2024. So you might, those of you who were here, recall that we gave presentations to, I think, 10 avionics and GNC projects across 5 different domain areas. And today, rather than trying to present all of those projects, because that's quite a lot, we decided we'd pick 2 of the particular domain areas to talk about in a little bit more depth. So we're going to start with the new architectures for data handling systems, the NADA projects. So to introduce what we did there, we asked for proposals for advanced architectures for data handling systems or onboard computers for future space transportation. And we suggested 3 topics that people might want to suggest ideas on. So one of them was low-cost modular avionics. Another one was time-sensitive networking or upgrading time-triggered Ethernet interfaces to interface the spectrum of its usage for launchers. So that's a way of getting larger bandwidth, better quality of service with deterministic data transmission protocol. And the third one was wireless technologies. And in the way that we do for firsts, we asked for de-risking the main elements of a disruptive technology in a pretty short time scale. So we asked for this to happen in 6 months. They would reach TRL 4 or even 5 by manufacturing and testing a breadboard. And we had 3 successful companies bid to that area, and I'd like to invite representatives from all 3 companies to join me here on stage. So I'd like to invite Marisol Malara, the division head of space avionics and equipment at GMV in Spain, Jonathan Rogers, the project manager from Realtra in Ireland, and Nicolas Huard, the flight systems division manager at Space Application Services in Belgium. So if all 3 of you could join me on the stage. So you have 2 microphones between the 3 of you. And you'll be presenting, yes. It really doesn't matter. Oh, you have 3 microphones. Great. So Marisol, I will start by giving you the floor and ask you, left or right, ask you if you could present the work that GMV did on the DDS over TSN project.
Okay, now it's okay. So my name is Marisol Melara. I am from GMV Spain, and today I'm going to give you a very brief introduction about data service distribution over time-sensitive network. That is the project that we run in the frame of these activities. So just very few words about GMV. GMV is a spin-off from 1984 from the University of Madrid, and in the last 42 years it's grown very much, arriving up to 4,000 professionals. We are present in 12 offices in 12 countries, and we run projects in 80 countries. But let's talk about the technical topics that we have today. This DDS, it's a middleware that allows to make an abstraction layer between the application software and the, let's say, avionic bus that is below. In our case, since our avionics solution is based on TSN, basically the DDS is adding more modularity and scalability to our already deterministic solution, but also guaranteeing the possibility to have to reinforce the quality of service that is already let me say that is already implemented in the TSN itself. So very briefly at the GMV, you can see here in the picture below, there is an avionic test bench with a full avionic representative of a micro launcher with its IMU, with its analog sensors, and also a TVC. And we basically developed this library that has been developed according to the critical software rules, so in principle could be ready for the qualification, and we have run a complete test with the full avionic, basically virtualizing the GNC and how in the application software is addressing the IMU and the TVC. Reaching the TRL 4, but we can say that we are close to a TRL 5 because basically this application has run on real hardware representative and with critical software as application software, so fully representative environment, and we are quite happy with the results because this library has added a very low computational effort on the CPU performance overall, and also a very low footprint. And this confirms also the interest that NASA has in this technology, being it used, for example, in the first launch of Orion mission, allowing to basically connect if I don't remember wrong the number, for 100,000 sensors, and so visualizing them. That's
That's great. Thank you, Marisol. And now if you could pass the clicker over to Jonathan, who will talk about the project they've been doing, in this case on the TTE technology.
Thank you very much. So my name is Jonathan Rogers. I work for Realtra. We're a small company based in Dublin. We've been allocated from part of the FLPP for the new architectures for data handling systems. And to do this, we were three different. Oh, sorry. The main directive of our company is to enable COTS electronic systems to work reliably in a space environment. So we have a number of products that we create. We dramatically reduce the life cycle costs and risk to operate electronic systems in space by fusing our space know-how with terrestrial COTS technologies. So basically, we look at the commercial aspects of different electronic devices and we make them robust for space applications and try to perform integration on different modules to see what synergies we can get from them. The main ones we would have is GNSS receivers, network switches. We'd like to thank even the FLPP program for us, because we've been able to develop several of our network switches and GNSS receiver that have already flown on the Ariane 6. As you can see there, we also have camera devices as well that we also have flown on Ariane 5 and Ariane 6. And we have thermal control units that will be going on the next PLEU mission. So as I move on, so this program now is an expandable, affordable, modular, time-triggered Ethernet solutions for space applications, or as we put that short as example. So what we want to do is demonstrate the capability of new architectures for data handling systems. And in order to do this, we partnered with two other companies as part of the FLPP program, one being TTE Tech from Austria and another one being Spin from Germany. We have done a previous program with the FLPP with TTE Tech to develop TTE Ethernet network switch. This is going through qualification as we speak, but it also has 4 gigabit Ethernet channels and 200 megabit channels, as well as RS-232 control and SPI interfaces. So we used this in order to bring in a GNSS receiver, as well as plug into the MA61C small sat interface card, which comes from Spin. The purpose of this was to bring in legacy signaling, as you can see on the right-hand side, through CAN bus, mil standard, RS-232, RS-485, bring in an SPI interface over the TT Ethernet switch. Combined with the GNSS receiver, we would get UTC timing stamping, put it onto the Ethernet, and also combine that with interfacing of all of these legacy formats. So 2 different goals there. One was to bring in the GNSS global time reference for time stamping, and the second one was to bring in the legacy interfaces from the MA61C CubeSat board. So as you can see, the hardware laid out here. What we did then is we put them all into one configuration. Then when we put them all together, we made sure that the GNSS time stamping could be done first. Then we did the legacy architecture coming through, and then we could put traffic from one side of the system through to the other and recognize this all over Ethernet. So the outcomes of this was to demonstrate the network frames contain the time stamping, as I said. This will identify the local time when the data was created. This will be taken down from GNSS receiver, which would have the Galileo satellites in orbit. We then put that in UDP packets containing the timestamp for best effort TT board switch traffic. These nodes can then participate in the global syncing of time offsets between the nodes, and we try to get that as low as possible. And the data successfully transmitted and received between nodes over the legacy interface formats, and we did this all successfully. So thank you.
Great, thank you. Now, if you can hand clicker, if you can hand the clicker over, Nicola, we'll talk about the work that space application systems have been doing on a software-defined TSN router.
Thank you. My name is Nicolas Yo. I'm in charge of the hardware flight systems at Space Application Services, and I will be presenting the work that we did for NADA. So this is the best bad corporate slide I could come up with. Just to summarize where we are in space, we are specialized in exploration, which is manned space flight, but we also do launcher. There is an obvious link with it because when you dock to a space station, there is a network in between, so that's where we come in. We delivered the Ethernet system of Dream Chaser. We deliver time trigger Ethernet switches for the Lunar Gateway, and we still do legacy Ethernet work on the ISS, mostly on Columbus. Okay, so I had to simplify the engineering diagram, so please excuse the simplicity of this drawing. This is the breadboard that we came up with. I have to reframe what we wanted to do. We didn't want to lock the swap right away. We wanted to explore the TSN capabilities in all of its, let's say, corner spaces. So we developed a TSN switch router, which also includes TSN Wi-Fi. There are some reasons for this in a reusable spacecraft, which we can come with later. So at the left, you have the design under test, and it's an 8-port gigabit switch, and it has layer 2 entirely in the FPGA hardware, and we do layer 3 switching, routing entirely on the software layers in as close as vanilla Linux stack as we could on this particular platform. And we have all the analyzer and traffic generators that is, let's say, symbolized on your right. The result is a bit messy as all the breadboard. It's not as neat as the GMT ones. But you have the design under test on the table at the center here. We have a big Versal Edge FPGA and the flight relatable PHY also. We could demonstrate your basic toolbox for TSN, which is time synchronization, all the time-aware credit-based shapers, but we did a little bit more than that. Of course, we could achieve tens of nanoseconds synchronization in arrival time, which is not easy to do. Of course, that does not hold over the air. The Wi-Fi TSN is a different beast. But we can also do VLAN, and we can do all the advanced inspection that you can do in layer 3, which is to support security features, of course. Yeah, okay. Thank you.
Excellent, thank you. Great, so I will show us a picture of all this now so it's fair. So no, thank you for 3 really interesting projects and all of which have gone successfully, I hope. So a question maybe just to ask all of you. Have you found that the process we've used in FIRST, so what Lewis was talking about earlier with the OSIP call, the pitch day, and then the ITT, helped you to interact with potential users so that you would develop a product that fits the market needs?
I can maybe start. Yes, I think we were a bit, let's say, unfamiliar with the process at first, but I have to say the informal part is very, very useful. The coffee machine talk and the breaks. There is the formal introduction, which helped us a lot, but I think it's the talk that we do at the coffee now and tonight that helped us a lot in trying to understand the market.
Yes, in our case, it gives us also the opportunity to involve some potential user of the technology, like in our case, the collaboration with Sirius micro launcher that for sure can improve the networking that there is in the space ecosystem. And this is kind of activity that you can do only if you have no pressure for the launch. So basically, you have a side track where you can develop technology and improve things into the future.
Yeah, I completely agree. And the last time I was here a year and a half ago, we got the opportunity to meet multiple partners like themselves. We've worked well with TTU Tech over not just the previous project, but it's led on to this NADA project we're on now, and it's opened up to other suppliers and other partners that we can also synergize with going forward.
Okay, great, thanks. And to ask a slightly different side of things, I think we asked a fairly open question in the first call, and the three of you have all done slightly different, different things, different parts of the jigsaw puzzle. In order to actually use it on a launcher, presumably we need to fill in those gaps in the jigsaw puzzle that are still left. How might we do that? Is that through FIRST, or is that through some other way?
Depends. But there are some maybe for the maturation and to go to ITRL is not the first let me say option, but could help, of course. While to push new ideas, to bring new concept on the table, FIRST for sure it's the best way to do it. But I mean, by talking and networking like in occasion as today, this can be also find a way forward.
Yeah, so things like this and the ESA Star has been great with us. We've managed to see all these different suppliers, partners around Europe, really opened up the market to us, so we can see capability that maybe we might have synergies with. We found that, for example, they do a similar switch to us using some of their devices we were talking about today, which is something maybe we could probably work on going forward. So just being able to have these associated beacons, especially in this ESA FIRST, has been a great first step at least.
Okay, excellent, thanks. I think we have a very quick answer to this one. So here we have two different and competing standards represented, so TTE and TSN. Do you think that both of them will have a place in the launcher world, or do you think it will end up being one of them, and if so, which? And we have to take a photo in 30 seconds, so quick answers.
Well, thinking about the perfect world, why not have both of them working together? But we know that this is not going to possibly to be implemented. I think that probably we will see a dichotomy, no? Two different scenarios depending on the kind of launcher and of the kind of application.
If you want to reply to that.
I think you can have both, because vehicles don't just generally have the one network. You can have multiple solutions to this, so you can have certain aspects of a network that might be better for, as opposed to the overall structure.
Okay, and I think that's as far as we're going to have time to take it. So please do catch all three of them in the coffee break. I believe we're supposed to take a photo before we let them escape.
Yeah, step up the photo,
So
please.
we. Thank you. Excellent. So after that fairly networking and software-based thing, we would also like to discuss a second project, which was the low cost and autonomous flight termination systems. So what is an AFTS, or an autonomous flight termination system? At highest level, it's an autonomous safeguard unit which can determine the location of a launcher and make a neutralization decision if it's not in the place it ought to be, without supported ground systems. These are something that's been identified as a key technology for reducing the operational costs of launch activities, particularly letting us increase the cadence and letting people operate from new launch sites which have less existing ground infrastructure. So once again, we asked industry to look into de-risking the main elements of disruptive technology in relation to AFTS. We gave them a 12-month time frame to reach TRL 45 by manufacturing and testing a breadboard. Without revealing too many spoilers of the talks we're going to have, the expected solution was always going to be a combination of satellite navigation and inertial measurements. And so we particularly asked if they could look at topics of robustness of GNSS solution against interference, jamming, spoofing, and so on. Maybe some links to the topics we talked about earlier today. And cost effectiveness of IMUs, because the typical IMU for a launcher is very expensive. So again, I'd like to invite representatives from the three winning companies on stage. So Luis Sanchez from Launches and New Programs at Sinair, Fabio Scavona, Senior INS and GNSS Navigation Engineer at Cascom, and Gabriel Topel, Project Manager at GMB in Poland. So if three of you could join me on stage, then we can start our presentations. So in the order you're shown on the screen. I'll invite Luis to start the process off.
Sorry, good afternoon, everybody. Well, I'm going to talk for 3 minutes about the status of our program. For those 3 minutes, I want to spend 30 seconds talking about my company, Sinair, instead of putting you instead of putting you some figures and so on, I prefer to put some images about our three major pillars of our space structure, the electromechanical system that has always been our forefront, and maybe we are more known about those systems, communication and navigation system. I'd like you to pay some attention to the Vega C photo on the corner. No, Naviga is our navigation unit that starting on 2027 will be the primary navigation unit for Vega C, and that it is the backbone of our AFTO solution. So what we have done, Lowcraft has been a stepping stone on our development program that started quite a few years ago. Several activities I would like to highlight. The safest program funded by the European Commission. Later on, we started with Lowcraft, but we are to it right now, and that's why we are here. So our objectives with Lowcraft are to complete low-cost, reliable, automatic flight termination system solution, as I said, based on our Naviga unit. With the objective of reaching TRL6 during this program. And we established a very successful consortium with our friends of Labor Space, Maya Space and Doya, in order to make this work. You can see on this photo a messy photo of our breadboard. That is the real doing test right now. So the results that we obtained has been to complete the complete firmware development for this unit, the complete design of the complete to reach this TRL6 level that we have advanced before. We have injected some tracking inputs coming from trajectories into our system in order to verify that the mission properly. So nowadays the system is completely ready for integration and hardware testing and to go further in future activities. So this is, thank you very much.
Excellent, thank you, Luis. And now I'd like to ask Fabio to talk about the project run at Cascom.
Thank you, and good evening, everyone. It's a pleasure for me to be here. My name is Fabio Scavona, and I am a navigation engineer in Cascom. What is Cascom? We are mainly a company which have core business on satellite navigation technologies. Our core business is based mainly on space receivers for LEO and Moon application, professional GNSS receivers for testing satellites and sensor stations, and satellite navigation simulator for testing receivers before the missions. Moving to the local project, what we have done. Our main goals was to develop a TRL-5 prototype of the FTU based on a failure-tolerant design. And as you can see in the picture here, our FTS systems is based on 2 autonomous flight terminations units. Each unit integrates 1 IMU and 1 GNSS receivers, and moreover, you can achieve a more robustness by integrating an external GNSS receivers in the overall FTS design. We designed our systems with a dual functionality potential, by using tactical grade IMU for GNC applications or lower grade IMU for safety range applications, so based on AFTS. At the same time, to test our systems, we developed an hardware-in-the-loop test setup based mainly on RFCS, radio frequency constellation simulators, emulated IMU sensors up to interface levels. So for our system, it's completely transparent to use an external or an internal IMU. And also emulated the launcher's interfaces, in particular for separation sensors, safe commands, and so on. And using this setup, we test systems in deviated trajectory scenarios. We used to introduce navigation threats and failures in these scenarios. So we cope with GNSS signal outages, GNSS receivers failures, IMU failures, and spoofing attacks in order to gain knowledge about the possible envelope of the errors in terms of position, 3D errors, and velocity 3D error. These kind of errors have a huge impact in terms of instantaneous impact point predictions for the fall down of the stages. And so we demonstrate with this envelope the compliance to the RCC 324s in order to be able in the future to certify our systems, because RCC 324 is nowadays one of the main standards. Next steps and roadmap for the futures, we will have to redesign our FTU hardware to reduce for sure the size and the weight of the systems. Most of the box that I showed you before is empty. We need support for carrier phase and differential heading for the systems in order to be able to initialize the inertial navigation systems in a completely independent way with respect to external informations. And then we will improve our automatic testing and Monte Carlo simulation capability for sure. Roadmap for the future, 2027 to reach a TRL-7 systems with demonstrating an operationally relevant environment for our FTS, and then 2030 reach with a flight-proven certified FTS, hopefully. Thank you for your attention.
Thank you, Fabio. Now, if I can ask you the clicker, please, to Gabriel to talk about the project of GMB in Poland.
Yeah, thank you, David. So, hello, my name is Gabriel Tofka, and I am project manager in GMB Poland. So, yeah, I'm going to have 4 slides, so 30 seconds, no problem. Okay, something about GMB Poland. So, GMB Poland is, of course, a branch of the GMB group. Yeah, so we are in Poland from 2009. We have over 100 employees, from which at least 60 is in the space sector. So about the project, so there was few things in project that need to be addressed. So firstly, the neutralization logic. So we make research about the regulatory basics, because there are official documents about how we we can terminate the launcher. We have few scenarios. So as you can see, we have extreme acceleration, sensor outrage, straight up launch, right? So we are doing simulations in every of these scenarios. Okay. So about navigation, we have our own hybrid navigation algorithm. As you can see, is extended error state Kalman filter. So we take data from GNSS, from view, and from external, from data from the rocket. And based on that algorithm, we can make a decision about termination. So another subject in this project was spoofing and jamming detection. So we done that with Gdańsk University of Technology, and with their help, research few algorithms, and we are working to apply it to our hardware. Thank you.
Great, thanks very much. Don't put your microphones down because I now have some questions for all three of you together. So I'll start with basically the same question that I asked to the previous panel. Did you find that the first approach of inviting you firstly to make an ESA proposal and then to talk to people at the pitch day before making a formal proposal helped in terms of making connections with potential users or informing the consortium that you did this project in?
Yes, I will try to answer this question. For example, in our case, this was not the first project in which we tried to develop an FTS demonstrator. We already have collaborations with Space Lab and Avio in doing so. So they supported us in terms of a use case scenario for sure. And this project was financed by IZ in the first instance. With this project now, with ESA, we take charge of the complete design of the FTS systems in terms of hardware, software, and we ask support to La Sapienza University in terms of use case definitions, because usually launchers companies are kind of blocked in terms of sharing reserved information, in terms of trajectories, real IMU data, and so on. So we hope to have the capability, the possibility for the future to gain more experience by having additional use cases, additional companies will join to us in this development of the FTU. Right now, we use mainly simulated trajectories. Then we inject this kind of trajectories inside RFCS to emulate both IMU and RF data simultaneously. Okay.
And either of the other two want to?
Nice, green. Okay. Okay, no, just maybe to add under a programmatic point of view, no, I think that well, first of all the future space transportation team at ESA is making a wonderful work, making this activity go further. Has been able to put in contact we as an industry with the stakeholders that are the launcher community and the spaceport community. No, otherwise, as you were saying, it would be very difficult maybe to have this community working. So at that point of view, under a high-level programmatic point of view, it has been very, very useful.
Okay, great. And I think Fabio sort of already led on to a question I was thinking of asking a minute ago, but presumably one of the steps that comes next is a need for real-world flight test data. And I think, Fabio, you've already hinted at the difficulty of it, but what data do we need? When do we need it? And who would you like to get it from in this room?
Okay. No, I think that today there are many companies that works on micro launchers or expandable launchers or usable launchers, or big companies also, which can help in this for sure. Yes, usually it's a problem about which is related to legal aspect to share some kind of informations. Okay, so it's not easy. And I think that one of the main roles of ESA can be to help us in this process. When do we need this information? As soon as possible, for sure. About real sensors data, and also people which are really focused on flight safety, which have a really good background. Because, for example, in our case, CASCOM, a really good background in RF, in navigations, in GNSS receivers, and so on, but mainly is focused on navigation. FTU is navigations and a lot of rules in terms of flight safety and safety critical systems. So can be helpful to have, for sure, big companies and small launchers company helping us.
Okay, Gabriel, any thoughts?
Yeah, I'm actually agreeing. What we need to make it further is mostly data from launcher manufacturers. By data, I of course think about the trajectories and about the rocket specifications. Maybe not entire specifications, but some measures how much mass can it take, and so on, so on. And other thing for a while, which I thought about, is that it would be interesting to have data from the FTL incidents. So when the not automatic, but just FTL was used, and see why it was, on what premise, and so on.
Okay, and certainly if there's anybody in the room who could provide any data like that, we'd be interested to talk to you. I think I speak on behalf of all of the teams here. So we're running low on time. I think I can maybe ask one more quick question, which is what comes next? So are we ready to sell these things to launch service providers or spaceports, or is there another step that needs to be done first? And in 30 seconds, what is that next step? I'll just start with this.
Next step, of course, is to fly, but we have to fly as a passenger. Nobody would like to on a medium flight of our unit make our work as a primary unit. So we need to find some first flight opportunities on which we can be just a payload in order to demonstrate our capability. Yeah, I agree. Next step should be some flying tests, and yeah, we need to try it practically.
Okay, great. Well, it's good to hear that we are heading towards being needed. So I think for us, the next step is to stand and take a photograph. But while we're getting ready to do that, I'll ask for applause for our panelists, and secondly, to remind everybody that if anybody wants to know more about this topic, the Access to Space Club tomorrow will also be going into it in more detail. So we look forward to being able to say more about it then. So thank you, everybody.
Okay, great. Thank you very much, David. Thank you very much to all the companies presenting. Thank you for the water top. Okay, next up is, I probably shouldn't say this, but it's one of my favorite parts of our events. I just love the way everybody looks so happy when they get certificates. So it is time for the award ceremony for the winners of the first sustainability contracts. And this time is extra special because this will be the first time that Piero will be handing over the certificates to the winners. So in FLPP, we have already been active on the topic of sustainability for a few years. We see it as a real advantage for European industry. This is the reason why we've launched the first sustainability campaign, and we'll present the results of the call today. So Valère and Margot will present a little bit of background about what we mean by sustainability and how it applies to what we do. And then they will present the winners of the first sustainability call with their own certificates. And don't forget to take a photo with certificates with the winners. Valère and Margot, floor is yours.
Okay, thank you, Kate. Hello, everybody. So, okay, to explain you the logic behind the first sustainability call, let us warm up with the definition of sustainability. So here on top, provided by the United Nations, it has 3 pillars: environmental, economic, and social. At ESA level, this is well detailed in the ESA Green Agenda. I will not detail that at all today. But the point is, in FLPP, we are focused on technology maturation. So naturally, we are more focused on environmental and the economic aspects. But why did you organize the first sustainability in the first place? In fact, it is because we want that sustainability topic is easier to address and more business attractive for you, our industry partners. So we focused on promising technology for space transportation that are relevant for space transportation, has a business potential, a market potential, and of course, can reduce the environmental impact. The 3 requirements was important to mention. Now, a few numbers about the first sustainability campaign. We received 76 IDs from the call for ID, 26 from the invitation to tender. As you can see, a small majority from the SME bidding, and a similar amount between the research institutes and large companies. From the country bidding for the invitation to tender, quite well spread over Europe, 12 different countries. And further down the process, 8 activities has been selected, 5 of them for technology maturation, which means validation in lab of the foreseen improvements, and 3 of them system study, limited to system studies because they are a little bit less mature. All of them will last 12 months. So to conclude, I will simply say, see you in March 2027 for the final presentation. And I will give the floor to Margot, who will give you more details about the awardees.
Thank you very much, Valère. So from the other submission, we derive 4 ITT themes: space transportation vehicles, processes and manufacturing, ground logistic and resource storage, and materials and propellant, all with the goal of improving environmental sustainability. Those domains were chosen because they represent the environmental hotspot, meaning where there's the worst environmental impact in the space transportation sector. But this means this is also where we can do the best improvement. We were really glad to receive many ideas, and I would like to thank everyone who applied for this OSIP call. And among all the participants, we selected 8 awardees. And now the time has come to congratulate those awardees. We're going to start with the first domain, space transportation vehicle, improving environmental sustainability. And please give a warm welcome on stage for Percy Space. There you go. Congratulations, Jesus. There you go. You can pitch your ID. You have 2 minutes.
Can you hear me well? Hello, everyone. My name is Jesus Muñoz. I'm the CEO and co-founder of Per Se Space. And today I would like to present to you our system study, which is called Eco-Tethers, and how we are working on improving the space sustainability from our side. In a very short term, Eco-Tethers is a project in which we are developing propellant-free propulsion systems to tackle two of the main areas of application that the space sector, I think, needs to tackle during the next 10 years. One of them is space debris, and the second one is in-orbit servicing. And the question now is how we can have propellant-free propulsion in space. The answer that we came up with is by using the natural resources that the Earth offers to us. So the electrodynamic tethers is a type of technology that we are using. And this is a technology that uses two of the natural resources that we have available. One of them is the ionosphere, and the other one is the magnetic field. So when you combine these two resources together, what you get is a force that can be used for satellites to lower down their altitude and therefore serving as a space debris mitigation device, and also to upper up the altitude of the spacecraft and therefore having a propellant-free propulsion system for satellites and in-orbit servicing vehicles. Per Se Space is the company that is in charge of commercializing this type of technology, and we came from the European Innovation Council that put 5.5 million in order to develop this technology and be in the process that we are right now, where we can start talking with clients and define the use cases. And this is what the Eco-Tethers project is about. We are in partnership with Astroscale and with Thales Alenia Space in order to have a clear view of the use cases, the different requirements from a system level, from an interface point of view, in order to define how this technology can be brought to the market within the next 10 years. We have an in-orbit demonstration of the first prototype that is going to be in 2026, so at the end of this year, 2027. And this is going to be thanks to the ESA Flight Ticket Initiative. So many thanks, ESA, for the support of this technology. Let me know if you have any questions about the technology afterwards. Thank you.
Thank you very much, Jesus.
Pierre, you can come to give them the certificates, a quick picture, and then we move on.
So we will continue the awards with the next team, Processes and Manufacturing Improving Environmental Sustainability. Please welcome on stage 5M. Adam Doggle, please. Congratulations, Adam.
Right. Hello, everyone. Good afternoon. So I would like to introduce the company which I represent, which is 5M, and present our idea within the ESA-first sustainability. So 5M is a Czech-based company founded in 1992. So in this area, we have 30 years of heritage within the sandwich structures and composites. And in the SpaceX segment, we have been for more than 13 years. What started with some simple sandwiches and products for space missions developed into complex assemblies that you can see on the slide in front of you. The panels for example, Hubble telescope or the Roselle. And we contributed on the development of flexible solar array. And last but not least, within the FLPP, we have the development of dispenser, which was also the introductory point for thermoplastic composites. In spirit of continuation with this technique, we suggested or proposed for the ESA-first sustainability, in which the technology to de-risk will be the out-of-autoclave processing, and the goal will be to reduce the carbon footprint of manufacturing by removing an energy-intensive process. Since we are in space, it is quite important that this green technology will not reduce the mechanical properties of the composites. Therefore, the target application is something that is quite, let's say, destructive on the materials, and we will try to test these composites in harsh conditions which are exposed to cryo tanks. So thank you, ESA, for this opportunity. And if you have any questions, I would like to discuss them over the coffee break. Thank you.
Thank you very much, Anna. And now we're going to continue with the third team, ground logistic and resource storage, improving environmental sustainability. Please give a round of applause for OHB Czech Space. Congratulations, Vaclav.
Hello, I'm Václav Lazar with the OHB Czech Space. This is a part of the OHB group that you might be know. And I'm going to present you a StarGo project. Well, the project, I've called it Get Your Space Hardware a Train Ticket. Disclaimer, we are not going to launch your satellites with a train, but this project is all about the transportation that happens prior to launch itself. So the project is based on the 3 pillars: the standardization, sustainability, and the rail integration. And we truly believe that we are able to maybe dig into those topics and to actually provide the new maybe technologies and approaches for the on-ground transportation. So we want to leverage standard ISO 668 containers that you might know, and essentially we want to create multi-usable interfaces and absorbers, for example, to be able to transport with a rail network. For that purpose, we've partnered with Mitrans. This is a Czech railway company, and the OHB system group to provide us the end-user experience. We want to conduct the system study, and we will mainly focus on the feasibility and technical concept solutions for this application. So, yeah.
Thank you very much. And we'll finish with the last domain, so materials and propellant and improving environmental sustainability. Here we have many more. So please give a warm welcome to Avio, ETH Zurich, Technalia, Lofit, and Technische Universität Dresden. Congratulations. Congratulations. Please sit if you have space. And we will start with Fabrizio. No, sorry. You have to stand up again. There you go.
Good afternoon, everyone, and thanks to European Space Agency to be part of this event. I'm Fabrizio Ciuffa, and in Avio, I'm responsible for energetic materials, as well as chemical laboratory and propellants pilot plant. The project is led by Avio, but in partnership with Politecnico Milano and Reactive Technology, a spin-off of Politecnico of Milano. And the focus of the project is the assessment of low environmental impact innovative material in solid propellants. Innovative materials, I mean, in this project, aluminum, lithium alloy. So aluminum is a standard fuel for propellants. We would like to introduce lithium because lithium is a key element in modern technology, and from an environmental point of view, introducing lithium in solid propellants could grant, for sure, environmental sustainability and technical performance, because lithium acts as a scavenger. So the big amount of hydrochloric acid in the exhaust can be reduced by the presence of lithium. From a technical point of view, the key point of the project is to develop coating process technology in order to make lithium user-friendly in solid propellant formulation, as well as nowadays for aluminum. So we have a defined technical strategy starting from raw materials, chasing of raw materials, develop this coating technology, test, characterize, till to a technological demonstrator and assess the environmental benefit through LCA analysis. So let's move on to green propellant. Thank you for your attention.
Thank you very much. Thank you. We'll continue with you, Deborah.
Okay, thank you very much for the European Space Agency for inviting us. I'm Deborah Müller from ETH Zurich Space, and I would like to present you our project. Think for a few seconds how cool it could be to have your local garden tree being the backbone for the future space transportation. The idea what we had is coming from a bigger problem that we have. Mega constellations are increasing in low Earth orbit. It doesn't only increase the traffic, it increases also the problematic after the deorbiting. So the problematic of toxic pollution that you have in upper atmosphere. So what we want to do, that's where we step in, is actually use a novel material to be able to be used as a structure for spacecraft or space transportation. The idea is to use local enhanced wood using a thermohydro process to densify the wood in such a way that it actually gets closer to mechanical properties of, almost similar properties as aluminium, space graded, is RF transparent, is demisable, has low outgassing, and has also thermal insulation. The project that we proposed is a system study to identify use cases that we can have for space transportation, but also for spacecraft. And with a holistic approach covering candidates, screening selections of materials, of requirements, and feasibility assessment, life cycle assessment, and identify the technology R&D gaps that we have to actually bring that as a roadmap for materials for the future. Our consortia that we have chosen is ETH Zurich is a prime. We have Swisswood Solutions, a spin-off from EMPA and ETH Zurich that is specialized as the materials expert. Beyond Gravity, that takes the perspective of spacecraft.
and latitude that helps us for the LCA analysis and has the perspective for the space transportation. So we are looking for ride shares also in the future. So if you are interested to take future novel wood of your local forest or even garden, come to us.
Thank you very much, Deborah. And now we're gonna continue with Hazel. Please.
Thank you. Okay, thank you, ESA, for this award. I'm Isaac Larraga, I'm project manager in Tecnalia. Tecnalia is the largest center of applied research and technological development in Spain. We have more than 100 space-related projects, but for our team, that is the team related to new alloy development and metal circularity, is the first space-related project, and we are so happy. We are even printing specific patches for this project. So I came today to explain orbital project. Okay, so what is this about? Most of you know that nowadays many of the space structure are made with aluminum alloys. Okay, and normally is high carbon footprint and critical raw material dependent aluminum alloys. What we are proposing in Orbital project is to transform aluminum scrap into high performance space grade secondary alloys. In this way, we are planning to reduce the carbon footprint of the aluminum alloys up to 94%. Okay, so how are we gonna do this? We will use integrate computational engineering and experimental validation methodology for alloy designing. Okay, and then we will validate this new eco alloy by space broad level component, and this we will make in collaboration with Latitude, a French SEM dedicated to develop launching system, and our final goal will be to enable a greener space missions and future in situ recycling on Moon and Mars. Thank you very much.
Thank you very much. If you have a spare badge, think of us. Thanks very much. And we're gonna continue with Lofit. Please, Amador.
Well, thank you for the invitation and for the work. So my name is Amador Garcia, leading Lofit Composites. And I have an open question to the audience. It's, have you ever thought about a material that can survive, let's say, a launching process and disappear after your mission? So this is what we are doing. So we are leading a disappear project, that our main idea is using thermoplastic composite structures that are engineered to ablate and to minimize the impact during the reentry. For us, is key, the reentry, what happened with the material that we are working on. But for sure, we are not alone. At the end, we are Lofit Composites, we are working on thermoplastic composite material, but we have very nice partners. I know they are in the audience. So we have a research institution. We are going to study what happened with this material from the chemistry standpoint. Are we degrading a material? Which are the substances that we are releasing in the atmosphere? What happened with this substance? And with this information, we are getting an extra flavor on the LCA. We have the approach of the LCA for sure about the materials, about the process, But with this new information about the chemistry of these materials during their entry, we are getting second, or as we call the extra flavor of the LCA. But for sure, we have empty aerospace as an end user. We have Bern and Sabel over there, and finally, well, Arribes, that is in charge of all the LCA, and well, they are supporting also a lot. And from our side, myself and my colleague Andrea. So fully open to discuss any question you may have, and thank you.
Okay, and last but not least, please welcome Rafaela from TU Dresden.
Thank you very much for the opportunity. I am Rafaela from TU Dresden. TU Dresden is one of Germany's universities of excellence, and we are strengthening our role in the European space transportation ecosystem by engineering sustainability directly into core system technologies. With the project TP Rise, we built on several years of research into bio-based thermal protection systems. Our patented material TPC is derived from wood fibers and natural constituents. It has demonstrated technical feasibility, being flight tested on Rexus 34, and shown promising thermal and mechanical properties. TP Rise now advances the work toward industrial application. The project focuses on material optimization, qualification under relevant test conditions, structural integration into spacecraft systems, and systematic life cycle assessment. We are not claiming that natural materials are automatically more sustainable. Instead, we ask a fundamental engineering question. Can renewable bio-based materials meet the requirements of space transportation to contribute to a more sustainable and also eco-friendly design thinking within the space economy? By combining this material technology industry application, we directly aim to make the space industry more sustainable from forest to flight. Thank you very much.
Just to point the photos are not over. So
yes, sorry. Could you please come?
Can all the winners of First Sustainability Awards go back up on the stage?
Yes,
and we'll
please,
do one big group
for
photo.
a final group picture. Thanks very much.
Okay, that's it then for the end of block 2. We have another coffee break for people on the site. You can go and get a coffee. Please be back by 6 o'clock for block 3. And online, you can have your own coffee break and back online at 6 o'clock.